Yeah, basically, I mean, all I really need to know is how, basically, kind of like definitions of like measures of dispersion and like how like an outlier affects like the measures of central tendency. Kind of like the basics of it, sort of, in a way.
Okay. Measures of central tendency are mean, median, and mode.
Okay.
Okay? And that's all that means.
Okay.
Dispersion. Measures of dispersion tell you how spread out the data is.
Okay.
One measure of dispersion would be the range.
Okay.
The difference is between the smallest and the biggest value.
Okay.
Another measure of dispersion would be the quartiles. Because the range only gives you the small and the big, and if one of those numbers is an outlier, then it's not really that much of a measure of dispersion.
Okay.
And outliers can be found by a formula. If an outlier is more than 1.5 times the interquartile range, then it's an outlier.
Okay.
So you figure out what the interquartile range is, which is the third quartile minus the first quartile, and multiply that by 1.5, and if an outlier is more than that number, or if a number in the data set is greater than that, it's an outlier. Of course, that wouldn't answer how you get the low numbers to be outliers. All right, well, let's look at some of this stuff here.
Okay.
Where do you want to start?
Well, on the first page, number 2 and 3 kind of sum that up, and then we can move on.
Discuss how the presence of outliers affects measures of central tendencies. An outlier affects measures of central tendencies. Well, what would they do? How would they affect it? They're certainly going to make the range bigger, so that would be one thing, right?
Right.
In other words, if you look at this first table up here, if you were to throw in an outlier of, say, 10,
okay.
all of a sudden we have a range that is 85 instead, or 76 rather, instead of the current range, which is only about 6 or 7.
Exactly.
So outliers definitely increase the range.
Okay.
What else would they do? Well, they're gonna.
Would they change the standard deviation?
Well, yeah, they're going to change all of those measures of central tendency. They're going to change. Well, no, they don't really change the mean. They change the mean. They don't change the mode so much, if you think about it. In other words, if I put 10 in this list, the mode's still going to be pretty much the same, the middle number. It'll change maybe a little bit, but it won't cause it to change as much as the mean changes. The mean would change significantly if I put an outlier in there.
And it would change the median, right?
Yeah, that's what I meant, the median. It would change the median. In other words, there's 9 numbers in here now. But if you think about it, it doesn't really change the median. Let's say I replace that 86 with a 10.
Okay.
The median is still the 5th number.
Right.
If these were all in order. Well,
right.
The fact that that number is an outlier instead of in our standard range doesn't really affect the median. It affects the mean, but not the median. And it probably doesn't affect the mode either. The mode is the most common one. And an outlier usually isn't going to be the most common one. So I would say that it really only affects the mean and the range.
Okay.
Discuss how it affects the measures of dispersion. Well, I kind of did that all in once, huh? In other words,
And make it the range bigger.
yeah, what did I say about the measures of dispersion? Just a second, I have that in my book right there. Yeah, it spreads out the data. In other words, one measure of dispersion is range. And so it definitely affects the range. So I suppose for number 2, you could say the mean, and for number 3, the range.
Okay.
Widens the range, changes the mean. All right, shall we go to the next page?
Yeah.
Can you use a flash on this?
I actually did not. Do you want me to send you a better picture?
No. I'm just trying to figure out how it ended up so light.
Huh. Not sure.
In other words, the contrast.
Yeah. I mean, I can send you a better picture.
No, that's okay. No, I absolutely don't need that. As long as I can read it, and just, if I can't, you can help me read it. So let's have a look at this one. Do you need to do 4, or have you done 4? You've done 4A and B?
I kind of did B, but I don't know if I was doing it correctly.
All right, but you think you did A right?
Yeah.
You want me to look at it real quick or not?
Actually, I did number 4, A.
Median is spelled M-E-D-I-A-N.
Oh. Oops.
It's okay. Let's see. I don't think you want me to spend the time figuring out the mean, do you?
No, but the A is right, because I did that one in class.
Okay. The mean is just all of those numbers added up divided by 9.
Right.
The median is all of those numbers in order, picking the 5th number.
Right.
The mode is, there's 2 28.5s in there, it's the most common. The range. Standard deviation, you used the formula for it?
Yes.
Which is a complicated formula. It's the square root of x minus the mean squared.
Well, on the calculator, yeah, we do.
You got an easy
stat.
Okay.
Yeah. So, like, we organize the points or the numbers in order.
Did you put them in a list? Is that what that L1 was on the first page?
I was just doing that to remember. But
okay. But in other words, how'd you get this list of numbers in to get a standard deviation?
I went to stat and then edit, and then in L1 I put the numbers.
So you just make a list. I didn't know how to do it. So once you got a list, it's like L1, and then you ask for the standard deviation of L1?
Yeah. And then when you want to find standard deviation, you go second, vars, and then normal CDF, and then that's how you get the standard.
Okay. Let's see. B. Each DJ receives an annual bonus of $1,200. Find the mean, all of these things, including the bonus. So we just take the numbers that we have and add 1,200 to it and redo it, right? Now, those are in thousands of dollars. In other words, the 39 means he makes $39,000. So you add 1,200 to that. And then you just add 1,200 to each of those numbers. They're each in thousands. And redo part A.
Okay. So
now, right
we
offhand, something doesn't look right. First of all, what's this
Right.
2? The mean was 37.22?
Yeah.
Can't be the same. Right? The average salary has gone up by 1,200, everybody.
Right.
So the new
I was confused that you were supposed to add
new
it.
mean, the easy way to get the new mean is add 1,200. In other words, if the average salary is 37,000, then the average salary with the bonus is 38,200. That'd be the easy way. It saves you a lot of work, but it looks like you got to put that list into your calculator anyway. Once you got that list in there, you can pull up mean, median, mode, and range, and all of it, can't you?
Yeah.
Okay. In other words, there's buttons on the calculator for all of these things?
Yeah.
Okay. Well, the only thing I would say is the mean should be 1,200 higher. The median
Right.
would be 1,200 higher. I must be misunderstanding this. Each DJ, because it doesn't seem like this problem should be here.
No.
This doesn't require anything at all. And the median should be 1,200 higher because it's going to be the same median, right? I mean, it's not like half of them receive the bonus. That would make it a problem. But if everybody receives the same bonus, it doesn't change the order. So whatever, if the median was 38, that guy's getting a $1,200 bonus, and he's still fifth in line of the 9.
Mm-hmm.
Mode, yeah, add 1,200 to that, so the mode's going to be 29.7, or 29,700.
Okay.
Won't change the range because it's being added to the low and it's being added to the high. And the range is the difference between the low and the high, so that's not going to change. And I suspect it's not going to change the standard deviation. Because all it's going to do is take this normal distribution curve and raise it up by 1,200. Every spot on this thing is going to be 1,200 higher, so it should be the same standard deviation, I would think. It might change the standard deviation. I don't know. You'll have to tell me after you do it. All right. Let's see. Each DJ receives an annual bonus of 10% of their salary. Okay, now this is a little different. Well, in other words, it's not the same bonus for everybody.
Right.
That might change all of it. It might change the mean. The median, you could just add 10% to that to get it. But it sounds like you would have to recreate a list where every entry in that table was 10% higher, and then go through and come up with your 6 things again.
Right. Okay.
Okay. How did Part B affect measures of central tendency and measures of dispersion? Well, once we have the answer to C, we will know that, right? Remember measures of central tendency is what?
It is the mean median mode.
Okay, and measures of dispersion?
Is like the range.
Range and perhaps standard deviation. I got to think standard deviation is a measure of dispersion also. Even though my book didn't say that. One simple measure of dispersion is the range, so it doesn't say that that's the only measure of dispersion.
Okay.
Measures, yeah. I would think standard deviation would be affected also. But you'll know. In other words, once you have the answers for C, it'll be real easy to answer D as long as what D is asking is, how did it affect the mean, median, mode, range, and standard deviation? That's what D is asking for. How did C affect the measures typo? Oh, how did C? Oh, I get it. How did part D is how B affected all of these. Part E is how C affected them all. In other words, C was, or B was adding $1,200 to every single person. C was adding 10% of their salary to each person. And we already went through how each would probably affect that. So once you have the answers in C, you'll be able to answer D and E quite easily. Okay.
Cool.
So the Z-score must be 2 standard deviations plus the mean minus the mean all over the standard deviation.
Yeah.
That can't be it, because that would always come out to be 2, wouldn't it? No.
No, not necessarily.
No, you're right. It wouldn't. No, you're right. So is that the formula for Z-score, or is that another thing in your calculator that you get? No, it looks like you did it manually. So is that you take the mean, you add 2 standard deviations to it, and then you take that minus that and divide it by a standard deviation.
Right.
Okay, so yeah, so if the mean was 60, it wouldn't end up being 2.
Okay.
Yeah, okay.
Yeah.
I got it. Okay. So the Z-score...
The Z-score is, it is like...
0 in this case for B.
Yeah, and I guess the definition of it is like how far
away from the mean you are, probably. Yeah. Or really more like how many standard deviations are you away from the mean. In other words, in this case here, he was 2 standard deviations above the average height, so his Z-score is 2. Here, he was 0 standard deviations above the mean, so his Z-score is 0. So it basically seems to be that. It's a measurement of how many standard deviations you are away.
Right.
Okay, and then we have the, what's it called? It's called the 90, there's a rule, the 99, 95, 68 rule.
Yeah, I think so.
99.7, 95, 68. Now what that means is that 68% of the data will fall within 1 standard deviation. Okay?
Okay.
And what that means on the table that you have here, if 1 standard deviation was 3.5, so what it's going to say is that 68% of the people are going to fall between that and that, which also says 68% of the area under this curve is right there.
Okay.
95% of the area is within 2 standard deviations of the curve, which is from there to there. So 95% of the area, you know, if starting from there and going to there, 95% of that area is right there. And if you go out 3 standard deviations, you get 99.7%. So, finding the probability that he's between 65 and 72 is this area right here.
Right.
That's half of 95. right? It's not all of 95. All of 95 would be 95% of the people are going to be between 58 inches and 72 inches.
Okay, so would you divide 95 by 2?
Yeah, it's going to be 47.5%.
Okay.
And that looks right. In other words, if you're throwing darts at this thing, you would have about a less than a 50-50 chance of hitting this part. 50% of the curve is from there all the way to there.
And you said it equaled 47?
47.5%.
Okay.
What's all this stuff here?
Oh,
the low, the high. No. The mean and the standard deviation. Yeah. What's that say? L8?
It's the, I don't know what it means exactly, but it's the formula.
Lowest something, upper bound, lower bound, upper bound, mean, and standard deviation. That's what those four things are. It's the probability that an adult male will be greater than 72 inches.
Equals. Okay.
So what do you think it is? In other words, this area right there.
5%?
5% is both ends. That's plus this would be 5%.
Oh, okay.
2.5%.
Okay.
Again, half.
Okay.
Find the probability that a male would be less than 65%, or 65 inches.
Less than 65?
That's this whole area.
That would be
50%.
Oh,
That's
right.
half.
Okay.
That's half. Just if it's symmetrical, and these are, when you're looking at normal distribution curves.
Right. Okay.
Okay. So let's figure out his Z-score on the first test.
Okay. So on the first test, that would be the same score to 72 on his Algebra 2 test with average deviation.
So
Okay.
wouldn't the Z-score be 72 minus 62 divided by 5?
Yeah. 5. Okay. 72.
Okay, and then on his biology test, the Z-score is 75 minus 69 divided by 4.
69. Okay, so would it be 72 minus...
No, 75. He's got a 75 on his biology test. Minus 69, which is 6, divided by 4, which is 1.5. So which test did he do better on in comparison to the class?
The first test.
He outperformed the average better on the first one than he outperformed it on the second.
Okay.
Okay. You go to Dakota Ridge? I always thought you went to Chatfield.
No, I go to Dakota.
I was just telling a friend of mine today that I don't get very many students from Dakota Ridge, but I get a lot from Chatfield, and I couldn't quite figure it out why that would be.
Probably because we're on a block schedule too, so teachers are more available.
Oh, so I thought you might say that. Probably because the teachers are more available for tutoring, huh? Or for for
Yeah.
individual help.
Yeah, and we also have Lockheed Martin, people that come
Oh,
a few days out of the week.
I've heard that. Yeah, yeah, yeah. Okay. Find the margin of error for the survey. And the margin of error is plus or minus 1 over the number of students. So plus or minus 1 over the square root of the number of students. 1 over the square root. Why does your answer say 3 to 5%?
I have no idea, to be honest. I don't remember doing that one.
In other words, it looks like it would be plus or minus, what is the square root of 780?
780 is 27.92.
So that's the 3%.
Right.
Oh, that's not even 3%. That's, yeah, that's closer to 3 than 5. What's the reciprocal of that number? 1 divided by that?
0.035.
So isn't that the margin of error, plus or minus 0.035, or plus or minus 3.5%?
Yeah.
Now,
That would...
it depends on how they want your answer. In other words, what does that mean? Plus or minus 3.5%. I don't think it means going up to 5%. So I think the answer should be a single number. Let's see if I...
Yeah, I think how I got the 5% maybe was in 1 divided by the square root of 365.
Margin of error. Let's see if I can...
Yeah, that's how I got, what's it called? The 5, or 5%.
How did you get it?
I did 1 over 365, so I gave it like 3% to 5%.
So 1 over the square root of 365 is 5%?
Yeah. Well, it's 5.2 or 0.52.
Let me look up margin of error. That doesn't seem right to me. In other words, why isn't the answer plus or minus 3.5%? Which is what you get when you solve that.
Right, so it would just be 3.5.
I think so.
I don't know.
I think so. That's something I don't think my book has margin of error. So I can't find, hold it, maybe they do at the back.
Oh, I think I was doing the interval. So I did the second, I did B.
Yeah.
When I got...
In other words, I don't think the margin of error has anything to do with this 365.
Right. See, that's what I was doing. I just put it in the wrong spot.
Okay. Give an interval that is likely to contain the exact percent of all Dakota Ridge students who prefer Chipotle to Qdoba. Well, what do we have? We have 365 compared to 415. Wow, I can't believe I've run this whole session without this thing being open.
It's okay.
Well, it shows you that this is all about definitions and stuff.
Yeah.
In other words, there's not a lot of, it's not in the calculation, it's in the definitions. So we've got
Would you do
365 like Chipotle and 415 like Qdoba. Give an interval that is likely to contain the exact percentage who prefer Chipotle. Well, what is that percentage? What's 365 divided by 780?
.467.
So 46.7% of the students prefer Chipotle.
Mm-hmm.
So we need an interval that's going to be at that 46.7. Well, if we went 3.3% on either side of the mean, we would get that, right? In other words, I think, give an interval. What are they looking for there? Are they looking for the normal distribution curve?
I think it is the normal.
Well, except this isn't a normal. Oh, okay, maybe it is, yeah. Okay, so if that's the 50 mark, the mean,
right,
and we went 3.3% left and 3.3% right, we would be going from 46.7 to 53.3. So is that what they mean? They want this interval right here? In other words, if we use a 6.6%, I'm not real sure what they're looking for here. I have no idea, in fact.
I can ask my teacher. It's okay.
All right. Take a look at the next page. You have an iPhone, right?
Yes, I do.
It should be coming out crystal clear. I bet you have it set on a lower resolution.
Probably. I've dropped my phone quite a few times.
Well, I don't know that that would do it, but when you go to take a picture, if you look at all of the things on the side, you can set your resolution, I believe. And you might have it accidentally set on the lower, because most pictures I get from iPhone users are crystal clear. I mean, it's so good that I immediately recognize that they took it with an iPhone.
Yeah, I was probably shaking. I was kind of cold earlier.
With the light. No, it's a resolution, because I don't think it's shaking. It might be. It might just be a little bit of shaking, but I don't think so. I bet you've got a setting off
Probably.
on your computer for calculator. Or maybe it's when you go to send it is where you set the resolution, because obviously you can send files that are low resolution quicker. They're smaller files than if it's really high resolution. So they may have an option on there that lets you set the resolution before you send it also. I don't know.
Right.
All right, let's look here.
All right. So, you could just type that into L1 and L2. And
Well,
that's the answer.
hold on a second. They want an equation that models it linearly. Oh, I see. You're gonna make a table and get a linear regression.
Yeah.
Actually, that's probably the way you want to do this. And that's the way you're going to have to do it, because this is going to be a linear regression, this is going to be an exponential regression, and this is going to be a quadratic regression.
Right.
I could figure out how to do the linear one, because it's easy enough to figure out slope.
Right.
Then you would have slope and a point, and if you have slope and a point, you can come up with this equation. So we could do this one manually. Doing this one manually, I'm not sure I know how to do that. But I know how to do it if you have two lists and a calculator.
Right. So would the second one be a quartic?
No, the second one is an exponential regression.
Oh, okay. And find it on my...
Should be there, I think. You have a TI-84? You have a 83?
Oh, there we go. Found it.
Okay.
Y equals 50.32 times 0.96 raised to the power of x. That one was easy. And then
Quadratic.
and that would be y equals 0.01.
Oh, so you already have this in your list, huh?
Yeah.
Okay.
And then that would be x squared plus, that would be minus 1.74 x plus 51.25.
Okay. You probably should have written down the r or the r squared at the same time you did those, because part D, that's what you need for part D. Which of these answers do you feel best models the data? That is given to you by the R when you do regressions.
Right.
The higher the R, the better it models the data.
R squared.
Huh?
Should it be just R or R squared?
You know, I don't know. I gotta think that R squared is always... Let's see, if you're squaring a number, it gets smaller. As long as you use R squared or R, either one of them is going to tell you which one models it best, I believe.
Okay.
In other words, if I have an R of 0.7, R squared is 0.49. Well, if I have an R of 0.6, R squared is 0.36. So relative to one another, they're the same.
Okay. Okay.
Well, let me guess. I'm guessing it's not linear. I'm guessing it's B. Has the highest R.
Yeah.
The exponential. The reason is, is because if it was linear, and I went from 10 to 45, that's increasing by 4.5, but this is, the mistakes are decreasing by like 60. It's linear would be similar changes, percentage from each of these. Determining whether it's this or this would be tough, because exponential looks an awful lot like the right side of a parabola, right?
Mm-hmm.
In other words, exponential looks like this. Hold on. This is exponential. Well, this is a parabola. So distinguishing between those two, you're almost going to have to use an R score to do it. Did any of them give you a high R? What was the R score on B? Did you get it?
The R square is negative 0.99.
That's a good R score. It's the absolute value of the R score that you want. The fact that it's negative merely means this. In other words, it doesn't grow exponentially. It decreases exponentially, like that.
Mm-hmm.
Or I really should draw it like this, I guess. In other words, your mistakes go down as the practice time increases.
Right.
the R positive or negative on C? On the quadratic?
The R squared is positive.
Well, R squared is always going to be positive. That's probably why R squared is positive. I mean, that's why there's an R squared, so that it's always positive. Because your R can be apparently negative. On B, your R was negative. Your R squared wasn't negative, was it?
On B, R squared was positive.
Yeah.
0.99.
In other words, I don't know how it could be negative. If it's just R squared, it's always going to be positive. So that's why they give you R squared, is because you can compare positive numbers to positive numbers. Instead of comparing a negative R there to a positive R there, and so forth. Okay, based on the answers you choose, predict the number of mistakes made by a typical student who has been in class for 100 days.
So would you just plug that into...
What's the equation that you came up with?
Y equals 50.32 times 0.96 raised to the power of 100.
Well, raised to the power x. So if you want to know how many mistakes somebody is going to make at any point in time, plug in whatever you want for x. In other words, in this case, 100. Yeah. And then you'll need to get that number from your calculator also.
Okay.
It's actually going to be a very low number. When you take 0.96 and you raise it to the 100th power, it gets very, very close to 0.
I got 0.84.
As the number, after multiplying it by 50, yeah, must have. So less than 1 mistake. Power of practice.
Yes.
It's probably pretty accurate, too. I took a typing class when I was in school. And
I remember doing it in like 4th grade,
really?
and now I'm finally fast enough at it.
Wow,
Yeah.
they teach typing in 4th grade now. I'm trying to remember what grade I was in when I took it. Maybe I took it that young. I thought it was more like 7th or 8th grade, back when I was that age.
Yeah, I went to Bradford, and they
Oh, they teach it.
they had all these like the Mac computers when they first came out.
Well,
So.
it makes sense now. In other words, you need to know how to type when you're in 4th grade. When I took typing, it wasn't for operating a computer keyboard. There wasn't any such thing. It was for typing on a typewriter. And most 4th graders wouldn't be doing that. But 4th graders definitely are typing on computer keyboards now. So.
Right.
All right.
Yeah.
Well, you got anything else?
No, not tonight. That's all I have.
Okay. Well, we both learned a little bit about statistics, I think, tonight.
Yeah, that helped.
Good. All right, Tara. I will see you.
Alrighty.
And we're staying on this day, right? We're staying on Wednesdays at 6?
Yeah, if that works for you.
Yeah, I think I put it in there permanently. Yeah, I did. Talk to you next Wednesday.
All right, sounds good.
Bye.